In this lecture, we will learn about remainder theorem. Remainder word is connected with the process of division. If we take two numbers and we divide one by the other, then it gives us a quotient and a remainder. Let's take one example. There are two numbers 15 and 6. If we divide this 15 by 6, then we get the quotient 2 and the remainder is 3. This remainder 3 tells us that the divisor and the quotient both are not the factors of this dividend. Or in other words, we can say since the remainder is not 0, so the dividend is not a multiple of this divisor as well as the quotient. Let's take another example, 12 and 6. These are two numbers. If we divide this 12 by 6, then we will observe that the remainder is 0. It means that this dividend is multiple of divisor as well as the quotient. Or in other words, we can say that 6 and 2 both are the factors of this dividend. This full process can be written as by one rule. That rule is dividend is equal to divisor into quotient plus remainder. In this case, it will be dividend is equal to divisor into quotient plus remainder. This remainder is deciding about the factors and multiples. Means if this is 0, then only the dividend will be multiple of divisor and quotient. Okay, so we have seen this. Now, the same thing we will do with the polynomials. If we divide a polynomial by another non-zero polynomial, then we will see the found quotient and the remainder. It will give us the clue about the factors and the multiples. So let's take one example. A dividend is a polynomial. P of x is equal to 2x cubed plus 2x squared plus x. If we divide this by another polynomial which should not be 0, that is suppose take x, then since this polynomial is divided by a monomial, so each term of this polynomial will be divided by this monomial and we can rewrite it like this: 2x cubed by x plus 2x squared by x plus x by x. So it will give us 2x squared plus 2x plus 1. So what we have seen, that each term of this given polynomial is being divided by this divisor and we are not getting the remainder, so remainder is 0. So this whole process can be written as this dividend is equal to divisor. Now what is the divisor? X multiplied by the quotient. So what is the quotient? 2x squared plus 2x plus 1. Since it is fully divisible, so the remainder is 0. So we can write this remainder 0 or we can leave it also. But suppose we are taking an example in which the remainder is not 0. Let's see, 2x squared plus 2x plus 1 is divided by x. Then again each term will be divided by the divisor. So this is 2x by x plus 1 upon x. This is okay. 2x squared by x, it will give us 2x. 2x by x will give 2. Now look at this. This term is not giving us the term of a polynomial, because in a polynomial the power of the variable should not be negative or a fractional number. So in this case we may say, since this 1 is not divided by x because it is not giving us the value as a polynomial, so we may say that this 1 will be the remainder. So how will we write it? We write it as the dividend, that is 2x squared plus 2x plus 1 is equal to. Now this much is the quotient and This term, simply we will write this one as a remainder, because this one we will not divide by this x, otherwise this term will not be a term of a polynomial. So simply we will write it as the divisor multiplied by the quotient, and this is the remainder. This is something what you have already learned in previous classes. Dividend is equal to divisor into quotient plus remainder. Since this remainder is not 0, it means that this divisor as well as this quotient both are not the factors of the given dividend. Or in other words, we can say this dividend, it's a polynomial, is not a multiple of x as well as 2x plus 2. But in this case, what we saw, the dividend, it was the multiple of the quotient as well as the divisor, since the remainder was 0. So now we will see further how to divide the two polynomials. Now we will divide a given polynomial by another non-zero polynomial, and the given polynomial's degree is greater or equal to 1. And second thing, what we are dividing it by means the divisor should not be 0. So two polynomials we are taking. This is p of x and this is g of x. We will see what we are getting the remainder, and after that we will conclude on the basis of the remainder. So let's divide. The first one is x plus 3x square minus 1. Always remember, whenever the polynomial is given, we will write it in its standard form. Standard form means in the descending order of the powers of the terms. So there the first one is not given in the standard form, so we will standardize it. Means we will write the first term as 3x square because it has got the highest power, plus x minus 1. It is to be divided by x plus 1. So the process is, the first term of the dividend is to be taken and it is to be divided by the first term of the divisor. Whatever we get, that becomes the first term of the quotient. So here 3x square is divided by x will give us 3x. So that 3x will become the first term of the quotient. After we get the first term of quotient, this is to be multiplied by each and every term of the divisor, and it is to be written under the like term of the dividend. So first term will be same because we have taken it in that way. So that will be 3x square. Now this 3x into plus 1 will be plus 3x, and it will be written under the like term. So that is 3x. Now we leave some gap and draw a line, because here we have to subtract this polynomial from this polynomial. Okay? So the signs are to be changed. So for that we will leave some space to write the changed sign. So this is positive, will become negative. This is positive, will become negative. Positive and negative, same values will be cancelled. Now plus x and minus 3x. It is plus 1 minus 3. So minus 2x is left out, and this left out term will come as it is. After this you may say that this is the new dividend. Then the process is same. The first term of dividend divided by the first term of divisor, and then that will give us the next term of the quotient. So here the next term of the quotient is minus 2. As we get the term of the quotient, that is to be multiplied by each and every term of the divisor. So 2 into x, but minus, so minus 2x, minus 2 into plus 1 will be minus 2, leave some gap, change the signs and consider the changed sign. Why are we changing? Because we are subtracting. And we subtract, and when we subtract, then the later parts signs are to be changed. So this is the second polynomial. From first we are subtracting, that is why we are changing the signs. So minus 2x and plus 2x will be cancelled. This is minus 1 and plus 2. The changed sign is to be considered. So this will be 1. So what have we observed? The remainder is 1. It means that this dividend, which is a polynomial, is not a multiple of the divisor as well as the quotient. Or in other words, the divisor and the quotient both are not the factors of the given dividend. Why? Since the remainder is not 0. So, we may say for any polynomial p of x whose degree is greater or equal to 1, if it is divided by another polynomial g of x whose degree is not, the value is not 0, and this we can write it as g of x, there exists another q of x, means this, the one which we are calling it as a quotient, we can write it as q of x. There exists a remainder in the form of polynomial, we can write it like this. So this is basically dividend is equal to divisor into quotient plus remainder. Okay. Similarly, we will do for other two examples also, and we will see what is the remainder. But before that, there is one interesting thing. If you substitute the value of x in the given polynomial on the basis of this divisor, without the process of division also, you can get the remainder. Let's see how. The divisor is x plus 1. Now take this divisor and make sure that the divisor should be a linear polynomial. Then only we will do this. So this divisor is to be equated by 0. This will give us the value of x. It means that if p of x is given as 3x square plus x minus 1, then p of minus 1, from where have we got this minus 1? From the divisor only. This p of minus 1 will give us directly the remainder. So in place of x, we will substitute minus 1. So this is minus 1, and this is minus 1. Now 3 minus 1 square is 1, plus minus 1, and this is minus 1. So this is 3 minus 2, and that is 1. Now look at this and look at this. Here we divided and we got the remainder. But here what we have done? We have substituted the value of x, and from where have we got that? From the divisor. We will equate the divisor by 0 to get the value of x, or the variable which is used in the polynomial. That value is to be substituted in place of x in the given polynomial, will give us this remainder. That only is remainder theorem. It means that if p of x is divided by any linear polynomial x minus a, where a is a real number, then the remainder will be p of a. Same thing we have done over here. This p of x was divided by x plus 1. So here, this value of x, how have we got? This x minus a is a linear polynomial. So here, what have we substituted in place of x? A. Means this x minus a is equal to 0 has given us the value of x as a. Similarly here, x plus 1 is equal to 0 has given us the value of x as minus 1. So, whatever is this linear polynomial directly can tell us the remainder without this division also. So, sometimes the process is asked and they can ask find out the remainder, or use the remainder theorem and find out the remainder and justify your answer. So, this is by long division. We have found the remainder, and here directly we have used the remainder theorem to get the remainder. Now let's see the second example. Here p of x is 3x to the power of 4 minus 4x cube minus 3x minus 1. It is already in the standard form. So we will write it as it is. And it is divided by x minus 1. So here the divisor is x minus 1. So same way we will write it, and the first term of the dividend is 3x to the power of 4. This has to be divided by x to get the first term of the quotient. So here 3x to the power of 4 is divided by x will give us 3x cube. This 3x cube is become the first term of the quotient. So 3x cube. This will be multiplied by each and every term of the divisor and will be kept under the like term of the dividend. So 3x cube into x. First term will always be same, that you remember. Why is this so? Because we have taken it in that way. So that this is the first term. Okay. So now 3x cube into minus 1 will be minus 3x cube, and we have got a term like x cube, so we will keep it under that. So 3x cube into minus is minus 3x cube. Now leave some gap and change the signs. This is minus and this is plus. This will be cancelled. Now minus 4 and plus 3. Minus 4 plus 3 will be minus. Minus 4 plus 3 is minus 1. With any variable, we don't write 1 or minus 1. So directly minus x cube. This will come as it is. Again, this has become the new dividend. Its first term will be divided by the first term of the divisor. So the new dividend is this, whose first term is minus x cube, divided by x will give minus x square. That minus x square is become the new term of the quotient. This minus x square into x will be minus x cube, and minus x square into minus 1 will become x square. But if you notice, there is no term like x square in the new dividend. So that we can write it separately. So this will be plus x square. Remember, this is minus and this is also minus. So this will be plus. Now change the signs. This will be plus, this will be minus. These two will be cancelled. But whenever we write a polynomial, we write in the descending order of the parts of the variables. So this will become the new term, okay, of the new dividend, and it is minus. So minus x square will be the new term of the new dividend. These two terms as it is will come down, minus 3x minus 1. Now the new dividend is this, whose first term is minus x square. So that is to be divided by the first term of the divisor will give us minus x. This minus x will become the new term or the next term of the quotient. Now minus x into x will be minus x square, minus x into minus 1 will become plus x. Change the signs. This will be positive, this will be negative, this will be cancelled. Now minus 3 and minus 1 will become minus 4. So minus 4x, and this will be as it is. Now the new dividend is minus 4x. We will go till we get the degree of this new dividend, you may say, or the remainder is less than the degree of this divisor, or its degree is 0. So here the degree is same. So one more step further we can go. So minus 4x will be divided by the first term of the divisor. This will give us minus 4. That minus 4 is the last term of the quotient. Now minus 4 into x will be minus 4x. Minus 4 into minus 1 will become plus 4. Now change the signs. This is plus and this is minus. Now this is also negative and this is also negative. So what have we got the remainder? Minus 5. Okay. One new step you have learnt in this. Whenever you are not getting a term having the like term in the dividend or the remainder, you will write it separately. And second thing what we have learnt, every time the left out terms are to be written in the standard form, means the descending order of the powers of the variables. So what have we observed? The remainder is minus 5. Now we will substitute the value of x on the basis of divisor. So what is the process? We will equate this divisor by 0 and we will get the value of x, which is to be substituted in place of x to get the remainder directly. So here the divisor is x minus 1 equated by 0 will give us the value of x as 1. So given polynomial is 3x to the power of 4 minus 4x cubed minus 3x minus 1. The remainder will be p of 1. So p of 1 is 3. Now 1 to the power of anything will be 1. You can just leave it also. Directly you can write this is 3. Similarly 1 to the power of 3 or 1 cube will be 1. So minus 4. This is minus 3 into 1 is minus 3 and this is minus 1. This plus 3 and minus 3 are cancelled. So directly you have got the remainder minus 5. So this is the use of remainder theorem to get the remainder directly. Now let's see the third example. Here p of x is given x cube plus 1 and g of x means the divisor is given x plus 1. Let's divide and see. The method is same. The first term of the dividend has to be divided by the first term of divisor to get the first term of quotient. Again and again I am repeating the same thing so that you will learn this process. Okay. So first term of quotient is x squared. Now this is to be multiplied by each and every term of the divisor and write it under the like term of the dividend. X square into x is x cube. This x square into 1 is x square. But there is no x square type of term in the given dividend. So we will write it separately. So this will be x square separately. Now draw the line, change the signs. First term will always be cancelled. Now when we write the left out terms, we will write the maximum power term first. So here this will be minus x square and this will come as it is. So new dividend is become minus x square plus 1. Method is same. The first term of the new dividend is to be divided by the first term of the divisor. So minus x square is divided by x will give us minus x. So that will become the next term of the quotient. So minus x into x will be minus x square. Minus x into plus 1 is minus x. Again there is no x type of term. So that we will write it as minus x separately. Draw the line, change the signs. This will be cancelled. Now this we will write first and this later because this power is 1 and here the power of this term is 0. 1 into x to the power of 0. So constant. So this we will write first and later we will write this. Okay. Now in this case when we have written this, this has become plus x and plus 1. So if we will simply take it as 1. Why? Because the new dividend, it is x plus 1. Its first term is x. X upon x will give us 1 because this is the same term. That is why I have taken 1 directly also. So this will give you same, change the signs. remainder is 0. Now the conclusion is, since the remainder is 0, so the dividend is multiple of divisor as well as the quotient. Or in other words, the quotient as well as the divisor, both are the factors of the given dividend. So this remainder also tells us about the factor and multiple. This is a multiple or not, or these two are the factors of the given dividend or not. Now let's see directly by using the remainder theorem how can we find out the remainder. So we will take the divisor. Divisor is what? X plus 1. Equate that divisor by 0 to get the value of x. Now, on substituting this value of x in the given polynomial, what is the given polynomial? X cube plus 1. So, we will find p of minus 1. Minus 1 whole cube plus 1. Minus 1 whole cube is minus 1 and plus 1 is 0. So directly we can find out the remainder and two conclusions. Sometimes it can be asked, find out whether the given polynomial is a factor of this polynomial or not, or in other words it can be asked, find out whether x cube plus 1 is one of the multiples of x plus 1 or not. Then to directly you can use the remainder theorem, and if remainder is 0, so yes, the given polynomial p of x is a multiple of this g of x, or this g of x is a factor of p of x. Clear?